Hello. Today, in this short little video, we're going to talk about solving quadratic equations. The last video we left off with, which was 9.3, which was technically in the first half of chapter 9, was all about solving using square roots. Today, we're going to take a look at another method of solving and when we have to use this. The square root method is convenient when it works, but it doesn't work all that often. So let's go ahead and get started right away. We're going to actually be solving quadratic equations by factoring, which is a skill that you have learned back in chapter 8 and probably previously as well. I want you to just take 5 seconds and think to yourself, if x times y equals 0, okay? If I have to multiply x and y and the answer is 0, I want you to think about what are some possible combinations. What could x and y be? What two numbers might multiply to 0? While I make this chart, go ahead and see if you can come up with some ideas in your brain. What's that? Yep, 3 and 0. Good. Who else? 0 and 11. Nice. Yeah. -1 and 0. Yeah, that'll work. What's that? 7 and 0. Yes, very good. And then one more. What you got? 0 and 13. Nice. So what we see here is that if two numbers are going to multiply to equal 0, one of the numbers has to equal 0. It is not possible for two numbers to multiply to 0 without one of them being 0. And that's going to be really powerful in what we learn about today. This is called the zero product property. You don't really need to know those words, but the moral of the property is what's super important. If two numbers are going to multiply to 0, then one of the numbers has to be 0. Okay. And how we're going to use this with factoring is if we have an equation that looks like this, I'm going to treat this first set of parentheses as x, or in the previous example, what I would have called x. So there's our first number, and here's our second number. Okay, so each set of parentheses constitutes a number, and now the question is, what value of x would make 0 in either set of parentheses? So what number could I replace both of those x's with so that when I multiply the numbers together, I will get 0? Okay, and the first one is, to answer that question, I want you to just think about, this is really pixelated, I want you to just look at the first set of parentheses. And what would you have to plug in, what would you have to replace x with to get 0 out of the parentheses? And a common answer that I get in class is 0. A lot of students say, well, I'll just put in 0. But as you see here, if I put in 0 for x, 0 plus 2 is not 0, it's 2. So if I want the answer to end up being 0, this would have to be -2. Now, if I did that in the second set of parentheses as well, I'll get -7. But that doesn't matter. It doesn't matter what the second number is because the first number was 0, right? Like, as long as one of the two numbers I'm multiplying together is 0, I know the answer is going to end up being 0. So one of the solutions to this equation, a value I can replace x with to make the equation true, would be -2, right? So that is one number that or one solution or one answer to this equation. Oh boy. Let's try this again. X equals -2. But there is another answer to this equation. And the other answer is, what would make the second set of parentheses 0? What could I replace x with to make x minus 5 come out to be 0? And it's essentially asking what number minus 5 equals 0. And that answer would be +5. Right? And again, I would have to replace both the x's with +5. But even if I did that, I would have 7 times 0, which would end up being 0. It's a little confusing right now because of the first time that we're seeing this. but these would be the two solutions for this quadratic equation. And again, quadratic just means that it has x squared in it. And what's sort of confusing is you don't see x squared right now. But understand that if we were to FOIL this or multiply the two parentheses together, we would have x squared in there. So two solutions, one from each set of parentheses. So let's try this again with this problem. So I'm going to highlight the two. So the first number doesn't even have parentheses. It's just plain x by itself. And there's my second number that I'm going to multiply. So the question is, what could I put in place of x so that the orange highlight is equal 0? Well, since there's no plus or minus anything, that solution would just be 0. If I replace both the x's with zeros, I have 0 times -9, which is 0, which is what I want. Okay. So what would make the other set of parentheses 0? Or what would make the other highlighted piece equal to 0? And that answer is going to be +9. Because if I were to take 9 times 9 minus 9, PEMDAS says I have to do the inside the parentheses first. And 9 times 0 does indeed equal 0. Okay. So these are my two solutions for that equation, because they're the two numbers that I can replace x with and get 0 as a result. So go ahead and give these two problems a try and see if you can find the numbers that would make each, the numbers you could replace the variable with to get 0. So as we go through this, I'm really just going to look at each set of parentheses separately, meaning I'm going to pretend that this set of parentheses doesn't even exist. So what number -3 would make 0? Well, that would be +3. And now if I take this out of here, what number +4 would make 0? That would be -4. Those are my two solutions. It's as easy as that. Okay. If I come over here, t minus 5, if I want that to be 0, well, then t would have to be 5. Or if I wanted t minus 8 to be 0, t would have to be +8. So those are my two solutions. Either one of those numbers I could replace the variable with, and it would give me 0 as a result. Okay. And so where we're going to go with this is the problems we just did, the two problems you did and the two problems prior, are already factored. They're already in sets of parentheses. So what we're going to do is, if we have a quadratic equation, we're going to go ahead and try to factor it to then use that zero product property to our benefit. Now, you might say to yourself, I really liked that square root thing that we did in the last video. I really liked just solving by square roots. And that method is great, but it doesn't work if there's both x squared and plain x. If there's both what we call an a and a b value, if there's both x squared and x to the first, then the solving by square roots method does not work. And so we have to try something else. So one of the other methods is to try to factor. So when I'm going to factor this, I'm going to ignore the 0. Now, I should pause real quick. That has to be 0 on the other side. This whole method falls apart if it's equal 1 or equal -5. Okay, this equation has to say equal 0. But now that it does, I'm going to focus just on the left side. And I'm going to focus on this x squared plus 7x plus 12. And if you remember, our factoring method was I want two numbers that multiply to 12 but add up to 7. So if I can find two numbers that multiply to 12 but add to 7, which in this case are 4 and 3, right? 4 times 3 is 12. 4 plus 3 is 7. Then I can write the equation, or write the left side of the equation in factored form as x plus 4 times x plus 3 equals 0. Just to reiterate, all we're doing is, if you were to multiply those two sets of parentheses together, you would get this. So I haven't actually solved the equation at all. I'm just rewriting it. I'm factoring the left-hand side, but now that it's written as two sets of parentheses, now I can go ahead and use that zero product property that we just learned about. What number plus 4 would make 0? Well, that would be negative 4. What number plus 3 would make 0? Well, that would be negative 3. So I want to show this one time just to make sure we're kind of putting things together. I claim that negative 4 and negative 3 are the answers. Okay. Now what I'm going to do here is I'm going to go to the calculator and I'm going to type in x squared plus 7x plus 12 just to really try to reiterate what exactly it is we're doing here. Okay. So if I go to the table, you can see right here, okay, and the numbers are kind of small. There are exactly 2 zeros in the second column, which is the y column in this table. There are only 2 spots where it's equal 0. And it's right here at negative 3 and right here at negative 4. Okay, those are the only 2 numbers where I can plug that number in for x and I would get 0 out for y. And I found that without having to go into the calculator and type it in. Now you might say, well, isn't that just easier to type in the calculator? Yes, but if the numbers are far apart or if they're decimals, the calculator tricks can be kind of tough. So that's where we can use factoring to really help us out. Okay, so let's try another one. Again, the equation has to equal 0, but the fact that it does means I'm going to go ahead and just ignore it for now. So I'm going to look at the left side of this equation and say I need 2 numbers that multiply to negative 24. Don't forget that minus sign. But they have to add up to negative 2. So 2 numbers that multiply to negative 24, meaning I need 1 positive, 1 negative, and it has to add to negative 2. So if you try some stuff for a while, eventually you'll come across negative 6 times 4 and negative 6 plus 4 is the number combination that I want. Now, these numbers are not the answers. I have not solved the problem. What I'm able to do now is I'm able to write this in a factored version. I'm able to write the left side of the equation as x minus 6 times x plus 4. And now that I've done that, now I can say, okay, what number minus 6 equals 0? And what number plus 4 equals 0? And those are just the opposite numbers. Okay. And again, if I went to my calculator to double check this, if I type x squared minus 2x minus 24 and I go to the table, there's 0 in the y column with negative 4, and there's 0 again with positive 6. So that's how we can use factoring to find the solutions to an equation. Go ahead, pause, try these 2 factoring problems, and we'll wrap this up. Okay, so again, we're using negative 24, but it has to add to positive 5. So I'm going to do 8. I'm going to do a different color. I'm going to multiply 8 and 3. I know is 24, but 8 and 3 make 11. But if I make the 3 negative, then I'm good. So that means x plus 8 times x minus 3, is going to give the factored form of that equation. So then my solutions are going to be x could be negative 8, and that would make 0, or x could be positive 3, and that would make 0. And those are my 2 solutions. Now, these examples all do factor nicely. It is possible that you can't factor something, and we'll talk about how to solve that equation in the next videos. What happens if I can't factor this? But there are 2 numbers that multiply to positive 15, but add to negative 8. And those are negative 5 and negative 3. So my factored version is x minus 5 times x minus 3. Don't forget the equals 0. Okay. Again, I haven't solved this yet. All I've done is rewritten it, but now I can figure out, or I can write down that if x is positive 5, it'll make 0 in the first factor. And if x is positive 3, it'll make 0 in the second factor. So those are my 2 solutions. Whew. We did it. We're doing it. Almost there. So how can I use my factoring skills to solve quadratic equations? First of all, we need to make sure the equation is equal 0. Make sure equation is equal 0. Factor the quadratic expression. That's a lot of mathy terms. Just factor the other side. Equation equals 0, factor quadratic expression, and then find the values that make each factor equal 0. These are the solutions. We did it, hooray!